Hello. In this video we're going to take a look at solving equations, exponential equations, using like bases. So like bases means that we're going to have the same number in the base on both sides. Our first example, we have 11 to the x equals 11 to the 9th. Now before we jump into this problem, let's do a quick review of exponent rules. Remember, if we have a to the x times b to the x, we can write that as a times b to the x. If we have a to the x times a to the y, we have a power times a power. We're going to add those exponents. If we have a power divided by a power, we're going to subtract the exponents. If we have a power raised to a power, we're going to multiply those exponents. If we have a fraction raised to a power, we can look at that as and split that up as the top raised to the power and the bottom raised to a power, as long as everything inside is either multiplied or divided. And we have, if we have something raised to a negative power, that's the same thing as 1 over that quantity raised to the power. So the ones that we're going to focus on are going to be these three in the middle here. Power times a power, power divided by a power, and a power raised to a power. Now we also have that if we have an equation where we have a to the x equals a to the y, then that only works if x is equal to y. So that's the one we're going to be using as the basis for these problems. So if our bases are the same, and all we have isolated on each side of the equation is that base raised to a power equals that base raised to a power, we can ignore those bases. We'll talk about exactly how we do that in a later video, and set those exponents equal to each other. All right, so our first example, we have 11 to the x equals 11 to the 9th, and that is exactly how this last rule is set up. And so because we have the same base on both sides, then we can just say those exponents are equal to each other. All right, on our second example, we have 2 raised to the x cubed equals 64 raised to the x. Well, we can't set those exponents equal to each other just yet because we have to have the same base on both sides. 2 and 64 can both be written as powers of 2. 2 is just 2. 64 can be written as 2 raised to the 6th power. We still have that x on the exponent out there, so 64 is the same thing as 2 to the 6th, and then that whole thing is raised to the x power. Now we're going to use this power raised to a power rule. We can rewrite that right-hand side. Power raised to a power, we're going to multiply those exponents. And so we get 2 raised to the x cubed equals 2 raised to the 6x. Now we do have the same base like we did in the previous example, and we can set those exponents equal to each other. X cubed equals 6x. The best way to solve this is to use factoring, so let's get everything equal to 0. We can factor out a greatest common factor of x, and we'll be left with x squared minus 6. So setting each of those equal to 0, we get x equals 0, and we get x squared minus 6 equals 0. We solve that by adding 6 to both sides and taking the square root. When we take the square root, don't forget plus or minus. And so we get 3 solutions here, x equals 0, x equals square root of 6 and x equal negative square root of 6. All right, let's look at another one that kind of like that. So here we have 4 to the x times 2 to the x squared equals 16 squared. So the first thing we want to do is write these all in terms of the same base. 4, 2, and 16 can all be written as powers of 2. Now when you're looking for these, you want to focus on powers, not multiples. So make sure that you are writing it as an exponent. So 4 can be written as 2 squared, and then that's still raised to the x. 2's already written in the base we want. 16 is the same thing as 2 to the 4th, and then we've got to square that. Alright, on the left-hand side, 2 squared raised to the x power is going to be 2. That's a power raised to a power, so we're going to multiply those exponents. 2 raised to the 2x. We still have 2 raised to the x squared. On the right-hand side, again, we have a power raised to a power, so that's going to be 2 raised to the 4 times 2, or 2 raised to the 8th. Now we're almost ready. We do have to make sure that everything is an isolated exponential, so we need to combine our 2 factors on the left. If we have a power times a power, remember we're going to add those exponents. So on the left, we can rewrite that as 2 raised to the 2x minus x squared. And then we still have 2 to the 8th on the right. Now we do have it in that form where we have a base raised to a power equals that same base raised to the power. So we can ignore those bases and just set those exponents equal to each other. And we get 2x minus x squared equals 8. That is a quadratic equation. And so we can solve this by factoring, we can complete the square, we can use the quadratic formula. I'm going to go ahead and try to factor this. I like having my x squared coefficient positive when I'm factoring, so I'm going to move everything to that right hand side. And I'm going to add x squared, I'm going to subtract 2x, and then we have a positive 8 on that side. When we factor that, we are going to get factors of 8 that add to negative 2. That means that we are going to have the same sign. Oh, I made a mistake. Let's go back and correct it. We had a power times a power, so we need to add those exponents. So please change that to a plus sign, which is going to change it to a plus all the way down. And so that means we actually want to move everything to the left-hand side. So our x squared is already a positive term, plus 2x, and then when we move that 8 over, we get a minus 8. All right, so now factors of negative 8 that add to 2 are going to be x plus 4, x minus 2 equals 0. So when we solve that, set each of those factors equal to 0, we're going to get x equals negative 4 and positive 2. You can check all of these answers using your calculator or plugging back in, whichever works. If you use your calculator, you're going to have 4 raised to the negative 4th times 2 raised to the, make sure that negative 4 you put in parentheses because you want to square the negative as well. That's going to be our left-hand side. And is that equal to 16 squared? It is. We can do the same thing plugging in the 2. We'll get 4 squared times 2 raised to the 2 squared also gives us 256. All right, I'll see you guys next time.